All right, hello everybody. I want to talk to you, or do a little bit at least, about these last two questions that we had as assignments. We had B2, I think this was 2014, the last day, or 2016, sorry, and this was 2014, doesn't matter anyway, you'll recognize them. I had a few queries from a couple of different people, one about setting up the angles in here, and the other issue people were having this morning were setting up these angles in here. So I'm just going to show you how to set up the question and kind of go through the basics of the drawing, and then I'll put up the solutions to the question then later on. Okay, so just I suppose to recap a little bit on this guy here first. Okay, so we were given, and let me just zoom in here now a little bit. We were given this picture, this shape, whatever you'd like to call it. Graphic shows an exit from Dublin's Port Tunnel. The outline of the exit is also shown as a line diagram in this thought bubble business. The problem people had was the setup, because I did do a video on this question already, and it was to do with 115 degrees and just the basics and the logistics of getting around that and getting that done. So I have a blank sheet here, and actually this was our solution anyway, but I'm just going to turn that over to the back for a minute, and I'm going to just draw the beginnings of that question on there. So let me just tape it on just for a minute, because I'm not going to spend too long doing this one. When you look at it, the angles are 115 degrees, which I think I mentioned on the video, even to you myself, that I don't have an adjustable at the moment, which means doing all these kinds of things is that little bit harder as well. And presumably not all of you have adjustable set squares either at the moment, and that also makes it more difficult for you. So I'm going to do this with that in mind. All right, I'll take that tip off now in a second. All right, so when I look at this first thing I notice, or the first thing I see, just waiting until the camera picks up on that. There we go. First thing I notice, the first thing I see is that I have a limited amount of measurements. I have 14 meters, I have 3.5, I have 3.5. I know it goes under a scale of 1:100. We had that already. I explained that in the last video. But this here is the issue, setting up this triangle. And to be honest, your starting point for this question is there, as in from Y down, that line, that axis, Y through C, and extending it on. Okay, so my first line that I draw is that vertical line that allows me to create the question off it, and I'm putting the vertical line in the center of the page. Okay, and putting a dot in there. Okay, so that is my 0 point, my corner, my center of the axis. And this is the line Y here. I won't put in point C just yet, because the next thing I have to do is I have to draw in the 115 degrees to the left and 115 to the right. Now, here's what I want you to do, and this is a trick, sorry, not a trip, a trick for evermore, or a tip. Actually, that's what I must be doing. I must be mixing trick and tip. Anyway, if you are ever unsure, right, remember that whatever is drawn here might not be the right size, but it is the right scale, which means the angles on it are correct. Okay, so what most of you would have probably tried to do, or some of you at least would have tried to do, would be to line up the point with that dot, and you would have tried to count down 115, realized your set square wasn't able for that. You need to turn your protractor, sorry, I said set square, but you need to turn your protractor on the vertical, and that's the difference in this question. And I need to measure down 115. And what I generally do, I never pick which scale I'm using, or at least I never really, I suppose, analyze that. I always say, well, where's the 0? And then I count up along the 0. So my 115 is there, not over here. Okay, so 115 is between 110 and 120, just there. So if I go back and apply that knowledge to my question, now I want to be a little bit more accurate than norm. So I'm going to use my vertical set square with this protractor. This protractor is accurate enough, but I want to be more accurate. So I'm putting it up there against the set square. I am lining up, and I'm going back very basic here as well, and this is for people that haven't tech graphics done. I'm lining up the center of my protractor, spot on that dot, and I'm counting 0, 10, 20, 30, 40, 50, 60, and up to 115. So there's my 110. I hope you can see that in camera. and there is my 115, and I'm putting in a dot. So I now know that that angle is 115. Okay, and then I draw in my line. So far so good. Now I need to do the same thing at the opposite side. So again, same setup. Vertical set square in order to keep it all nice and in order. And I count down again to my 110, and this time it gives me a dot there. And again, I draw in that line. Okay, and once more, all is well with the bird. Now, next thing they told us, so we've dealt with 115 degrees. This piece here, this 90-degree angle might have caused some of you some consternation, maybe not. Before I can put it in anyway, I need to put in that 14-meter measurement, which we discovered the last time was 140 millimeters. And that now means as well that if it's 14 for the full length from A to B, and they've already told me in this question that this is an isosceles triangle, that means that the distance to each side of that central line is equal. So it's 14 divided by 2, it's going to give me 70. So 70 millimeters. So I'm going to go measure out here from the edge. And in order to measure, I'm going to put a light line first of all, because you should be always measuring on a line. May not be possible, so I'm putting in a light line. I want to be accurate with this. So I'm measuring exactly 7 on that line. Okay. I could measure 7 out to the other side as well. And yeah, I would be correct. But the angles are the same. So why not save yourself a bother and draw in that line from point A straight across there to point B. And it gives me the point B. So now I have the line from A to B. Now, let me stand up and see what that looks like. Okay. So far, so good. Am I slightly off the screen? Or is that, am I imagining it? There we go, that's better. Okay, so there's A to B. Now, my next job then would be to complete that triangle. Now, this is sliding set squares. Now, the reason I'm using sliding set squares here, and I'm going to put that set square out of the way, is my angle that I need to look up at, right? In order to see that end view. Oh, my set square's upside down. That's why that's not working. So I will be looking up along this line, both to the right and to the left. All right, so I'm looking up in that direction. So I'm going to put an arrowhead up there because that's the way I'm looking, and an arrowhead up there in order to see my elevation and my end view. Now, in order to go 90 degrees to that line, the most accurate way you can do that, right? And this is sliding set squares again. Keeping my 90-degree angle of either of the two set squares up against that line or that edge. What I'm going to do is then place, and I need to check my camera here to make sure you can see this. You can now. I need to then place my set square, here it is, up against that line, and I slide that back, and that gives me that 90-degree angle that I am after, that I am looking for. And I then complete my isosceles, no, I don't complete it actually, sorry. I then draw my second side of my isosceles triangle, so it gives me a point up there. Now, by doing that, we've generated the 90-degree angle in there that they have asked us to put in, okay? And we have put in the 115. And actually, it has just occurred to me that I didn't finish off doing that tip with you. You can measure with your protractor on any question and actually check where the angles are or how the angles are generated. I mentioned that to you there a minute ago. Right, for the other side, I do the same thing. So one set square against the line that needs to go 90 degrees to. Other set square against that edge. Slide it up. And you're using one hand to hold both. And this is where having done TG for 3 years gives you experience, because you're used to doing these kinds of things. And you will be accurate and all those brilliant things that you can be with it. Okay, and I am slightly inaccurate. They're not meeting quite at the top point, but you could always join the point down anyway. So there's the rest of my triangle. Next thing then, and I think in the last video this is where I started from anyway. I did. I came up with a certain space. So look, that's the bit some people asked about. I hope that bit is okay with you. So that was for the tunnel question. Okay. The next thing you asked about, or some of you asked about there this morning, and there was more than one, is in question on this basketball hoop pitch, whatever you'd like to call it. I think what happened was some people expected it to be different. What they don't, well they do show you. I was going to say they don't really show you, but they show you quite clearly. Up here, look. Up here in the middle of the text, they tell us that this is incomplete trimetric projection, right? And trimetric means 3 angles. Literally. I'll come back to what that means in a second. This one, they told us quite clearly, was a dimetric projection, and that means 2 angles. Di for 2, tri for 3. Okay, and what it means is that there's 2 different angles on it, and in this one it means that there are 3 different angles on it. And axonometric is when it is 3 equal angles, and they're all 30 degrees, and they're the ones you've been used to doing, and that's why this is kind of thrown in. And that's the difference between the higher and the ordinary. Ordinary level will always be 30 degrees, higher level will be a different angle. I'm putting down another question, sorry. So anyway, so this one has 3 angles. Now, literally what that means is that the angle in here that is 110, that's one angle of the trimetric. The angle over here that I don't know what it is a different angle on my drawing, a different view, because we're looking at it in a different direction. And the angle down here at the bottom is going to be different again. So some people would have had trouble setting that up. Now, even if you hadn't spotted that was trimetric and it was going to be 3 different angles, I would have hoped that you would have spotted that the measurements will allow you to get point A and the measurements will allow you to get point B. But look, we'll work through it as if we didn't get that. So I'm starting off again, and like with the last question, my starting point is the center of my page. And again, I put in a nice vertical line, and they have that in blue. I better keep it in blue. So there's my vertical line. Okay, and again, I am going to go with, and here we are, 110 degrees on the left. So protractor out. Now I'll run out of space with this if I don't go high enough. It's kind of the same as the last one, I'm guessing, so I'm going to just put in a point there. So that's going to be my 110. Again, I should use protractor and set square lined up. 110 degrees is there. Okay, so there's the 110. Now, at this stage, some of you would have measured 110 to the right and then would have looked at the 40 and would have scratched your heads. Others of you would have measured 40 and then scratched your heads because it wouldn't have been the same at each side, and you would have been wondering what was going on. So just to go over, because I'm not going to draw the whole question here, I have covered or done at least that section, that corner there. If I now go down to, well, what information have I next? 50 and 40. Last time we had 70. So this time I'm going to measure out, and I'm going to put in a light line again to help me do this, to keep it accurate. Just a light construction line. We always want to measure on a line. So I'm going to measure 50 to the left, and I'm going to measure 40 to the right. And I will project that down. There's the point there on my angle, and in order to complete it, I need to now go over 90 from there. And where those 2 points cross gives me the angle that I need for that final piece. Now, it doesn't matter a bit what that physical angle actually is. What's the name of it, what's the number of it. But what I do know now is I've created everything that I need to create from in here. Okay, now, let me just move this camera a little bit. Okay, so 50's gone in, 110 has gone in. I have my yellow angle now over there at that side. And that is lovely. And I have the purpley one down here. And there's my 3 angles. So trimetric means that the 3 of them will be different. Now, we still have to proceed from there. So I'm still doing the same thing that I did the last time, which is I'm standing or imagining or I am projecting up from that view. So off in that direction again, doesn't matter what angle it is. And I'm going to do the same from over here. Projecting in that direction. There we go. And I am again trying to complete the triangle. So in this case, I am going and putting the T-square away here now because we're back to sliding set squares. I need to go at 90 degrees to that angle through my 40mm point. So my triangle, my axonometric plane, because that's what it is. This represents the plane. There it is, 90 degrees. You're always going to put that in at 90 degrees. Same up through here. And the horizontal line. There we go. And we're back to where we were the last time. I'll just go a little bit further on this one just so you know what it is you were doing. So the usual scenario, so this is totally sliding set squares now from here on. The usual scenario would be to project up the end of the triangle, so the ABC point. So I will project up here. I will project up here. And again, I will go at 90 degrees to that. And if you watch there, look, I just turned the set square at 90 degrees to line up. So I'll just line that up there. And I will bisect. At least I will when I find my compass. There it is. So to bisect, opening the compass slightly more than halfway. Sorry, now my dog has gone mad. Anyway, so opening the compass slightly more than halfway, putting it at the end of the line, scribing an arc, scribing an arc. Putting it at the end, scribing an arc, and where the 2 of them cross, that gives me the rotation point. No, not the rotation point, the center of the semicircle. So I go in there, and I rotate it. No, I draw in the semicircle. And remember, the purpose of the semicircle is purely to allow you to draw that 90-degree angle. And I draw it where my corner line comes up. So my 90-degree angle fits in just there. And I think you should be able to take it from there. Okay, so that's the main part of the question. I want you to try that. I want you to see how you get on, and we'll take it from there the next day. Thank you.